These are the four variables involved in study of motion: position, velocity, acceleration and time. If particle is moving and its acceleration is varying, then how acceleration is varying will be given to you. So acceleration may be defined as function of time t, or you may face a problem in which acceleration is given as function of position, or acceleration may be given as function of velocity. For example, a particle is moving along a straight path, that is rectilinear motion, with an acceleration 2t plus 1 meters per second squared, where t is time in seconds. So this is the relation between acceleration and time. Acceleration is varying with time according to this relation. When t equal to 0, acceleration is 1, and when t equal to 5, acceleration is 11. Here acceleration is given as function of position, or acceleration may be given as function of velocity. What is very important to understand, in variable acceleration motion, acceleration may be given as function of time t, or it may be given as function of position, or it may be given as function of velocity. Case 1. If acceleration is given as function of time t, then replace acceleration by dv by dt and integrate the expression. Separate the variables, velocity on the left hand side, time on the right side, and integrate. And what you will get is velocity time relation. Using this relation, you will able to find velocity at any particular time instant. If required, that is, if you want to know position of particle at particular time instant, or displacement of a particle at particular time instant, then you will have to find relation between position and time. And how to find out that? Simple. Replace velocity by dx by dt and integrate. So if you integrate acceleration, you get velocity. If you integrate velocity, you get position. Now second case of variable acceleration, where acceleration is given as a function of position. Now if acceleration is given as function of position, replace acceleration by v dv by dx. Replace acceleration by v dv by dx, separate the variables and integrate it. This is how we integrate acceleration, by replacing it by v dv by dx. And after integration, you will get relation between velocity and position. And if required, you can replace velocity by dx by dt and further integrate the expression to get position time relation. Case 3, where acceleration is given as function of velocity. If acceleration is given as function of velocity, replace acceleration by dv by dt, separate the variables in this manner and integrate the expression, you will get velocity time equation. If required, you can replace velocity by dx by dt and further integrate for position. Integrate acceleration, you will get velocity, integrate velocity, you will get position. But here you may replace acceleration by v dv by dx, so that by integration you will get relation between velocity and position. So remember now this, if acceleration is function of time t, replace it by dv by dt and integrate. If acceleration is function of position, replace it by v dv by dx and integrate. And if acceleration is a function of velocity, then as per the requirement, replace acceleration by dv by dt and integrate, or replace acceleration by v dv by dx and integrate. So this is how we solve problems on variable acceleration, and you will understand it better. A particle is moving along a straight line, that is rectilinear motion. The motion of the particle is governed by relation A is equal to t cube minus 2t squared plus 7 meters per second squared. Here acceleration time relation is given. So we know how to proceed. replace acceleration by dv by dt and integrate it. Okay, where t is time in second. At t equal to 1 second, velocity of the particle is 3.58 meters per second and position is 9.39 meters. Calculate position, velocity and acceleration of the particle at t equal to 2 seconds. Very simple, very straightforward problem it is, and not at all time consuming. How to solve the problem? Listen. Acceleration time relation is given. Replace acceleration by dv by dt, integrate. What you will get? Velocity time relation. And once you get velocity time relation, replace v by dx by dt to get position time relation. So integrate acceleration for velocity, integrate velocity for position. What is asked in the problem? Position, velocity and acceleration at t equal to 2 seconds. Now acceleration at t equal to 2 seconds, easily you will get, just put t equal to 2 here and get acceleration. But you will require relation between velocity and time also to find velocity at t equal to 2. You will require relation between position time also. So what is asked in the problem? Check it and create necessary equations. Listen, now I am telling you what do you mean by an equation of motion. Listen, 4 variables are involved in study of motion: position, velocity, acceleration and time. Relation between any two amongst these 4 variables, that is equation of motion. Means if acceleration and time relation is known, that is equation of motion. If velocity and time relation is known, that is equation of motion. If velocity position equation is known, then it is equation of motion. Relation between any two amongst these 4 variables, that is equation of motion. Here relation between acceleration and time is known, so this equation is equation of motion. Okay. Now acceleration is t cube minus 2t squared plus 7 meters per second squared. This is first equation of motion, and then other necessary equations of motions will create first. Of course, put t equal to 2 seconds, one answer you will get immediately, acceleration at t equal to 2 seconds. But better way to get other equations of motion. And one very important thing, when acceleration is not a constant, when acceleration is not uniform, then v is equal to u plus at, x is equal to ut plus half at squared, these equations are not to be used. So in this problem, you are not going to use v is equal to u plus at and x is equal to ut plus half at squared. Okay. So how to get velocity, position, displacement, etc. by integration. So now we know the standard procedure. When acceleration is function of time t, replace it by dv by dt, separate the variables and integrate it. So you will get v is equal to simple integration, t raised to 4 by 4, x raised to n plus 1 by n plus 1. So this equation simply we have integrating acceleration, you will get velocity, and t raised to 4 by 4 minus 2t cube by 3 plus 7t plus c. T raised to 4 by 4 minus 2t cube by 3 plus 7t plus c. What is that c? The constant of integration. This is not velocity time relation yet. In the sense, by putting t equal to 2 seconds, here you will not get velocity because you don't know yet c. So this constant of integration to be evaluated. And for that purpose, there is necessary information in the problem. It's given that at t equal to 1 second, velocity of the particle is 3.58 meters per second. So put at t equal to 1 second, v is 3.58 and it's given. So put in equation 1 in this equation. So this is how I have substituted v as 3.58 and t equal to 1, so that c is known as minus 3. Now put this c in equation 1 so that you will get perfect relation between velocity and time. So this is second equation of motion. These are the two equations we'll able to find acceleration velocity, but because position is asked, so we'll integrate velocity further. So dx by dt, replace velocity by dx by dt and integrate, separate the variables, check here dt is on the right side, and now integrate it. So it's simple integration again, x raised to n plus 1 by n plus 1. So t raised to 5, 4 plus 1, and then divided by 5, so 5 into 4, 20. So t raised to 5 by 20. So x is equal to t raised to 5 by 20 minus 2t raised to 4 by 12 plus 7t squared by 2 minus 3t plus constant of integration c dash. So to evaluate this constant of integration, do you have any information in the problem? Yes. At t equal to 1 seconds, velocity of the particle is 3.58 and position is 9.39. Yes. At t equal to 1 second, position is given as 9.39 meter. Put it in this equation, that is equation 2, and you will get the constant of integration c dash. Put that c dash in equation 2 so that you will get final relation between position and time. So this is equation 3, position time relation. So all necessary equations we have created. Remember, integrate acceleration for velocity, integrate velocity for position. This is how we solve problem on variable acceleration. Now put t equal to 2 seconds in these 3 equations one by one and you will get the answer. So simple calculations these are. Equation 1, equation 2 and equation 3. Now simply put t equal to 2 seconds in these 3 equations and you will get the answers. So very simple problem. Now important thing, find displacement at t equal to 2 seconds. Check, is it displacement at t equal to 2 seconds? No, this is position at t equal to 2 seconds. Remember, it is not asked in the problem, but I am discussing it with you to make your concepts clear about position and displacement. In exam, you may face exactly the same problem in which you are asked to find displacement at t equal to 2 seconds. And just putting t equal to 2 seconds here, you will not get displacement, you will get position. At school level, you have studied this. Displacement is change in position. Displacement is defined as change in position. It is final position minus initial position. So remember, x is not displacement, it is position. So how to find displacement at t equal to 2 seconds? Here we have found out position at t equal to 2 seconds. So we are going to use basic definition of displacement. So how to do that? Listen. Displacement at t equal to 2 seconds. Displacement is change in position. So position at t equal to 2 seconds minus position at t equal to 0. So position at t equal to 2 seconds, that is what we have found out already. This is position at t equal to 2 seconds. It is 15.93. And position at t equal to 0. Put t equal to 0 in this equation and you will get position at t equal to 0 as 9. And that is a displacement, change in final position minus initial position, and this is displacement. So try to understand, basic definition of displacement is change in position, and that is what we have used here. Read this problem. The acceleration of a particle is given by a is equal to 90 minus 6x squared centimeters per second squared. Now when you read this statement, immediately you will realize that equation of motion is given because it is relation between a and x. Acceleration is varying and acceleration is given as function of x. And now you know that how to solve the problem. When acceleration is given as function of position, replace it by v dv by dx and integrate it. Simple. Let's check what is asked in the problem. Where x is in centimeters. Okay. If particle starts with 0 initial velocity from origin, determine velocity when x is equal to 5 centimeters, position when velocity is again 0, and maximum velocity. So 3 things are asked. Let's answer the question. We know how to start solving the problem. acceleration is 90 minus 6x squared centimeters per second squared. This is first equation of motion. Replace acceleration by v dv by dx. Separate the variables and integrate it. So you will get v squared by 2 equal to 90x minus 6x cube by 3. V squared by 2 is equal to 90x minus 6x cube by 3. It's simple integration, x raised to n plus 1 by n plus 1. Now we'll have to evaluate this constant. Yet we cannot say that we know relation between velocity and position, because in this relation that c is unknown. So let's find out value of c. For that purpose, is there any information in the problem? Yes, particle starts with 0 initial velocity from origin. That means x coordinate is 0. So when x is 0, velocity is 0. So at x is equal to 0, that means at origin v is equal to 0. This is given. So put in this equation 1, and what you will get is c is equal to 0. So put that value of c in this equation 1, so that v squared by 2 equal to 90x minus 6x cube by 3. The equation or relation between velocity and position is ready. This is second equation of motion. So check what is asked in the problem. Determine velocity when x is 5. So velocity and position equation is v and x relation is required, and we have found out that. What else is asked? Position when velocity is again 0. Position when velocity is 0. Again position velocity equation is required, and that is already available. And you are also asked to find maximum velocity. So maximum velocity we can find out from this equation, but remember the condition for maximum velocity, acceleration 0, and acceleration is available here. So these are the two equations which are enough to solve this problem. Velocity when x is 5 centimeters. Simple. Put x is equal to 5 centimeters here. Now when you put x is equal to 5 centimeters here, you will get v squared equal to something. And therefore v is equal to root of that value, and you will get v is equal to plus minus 10 root 2. Try to understand what I said just now. When you put value of x as 5 here on the right side, you will get finally v squared equal to something, and therefore v. Of course, on calculator screen, answer will flash 10 root 2. This answer may be written in decimal format, but what I am telling you, listen to me very carefully. On calculator screen, answer will flash without positive negative sign. But you must know, you have studied mathematics, square root of something, it is plus minus. And velocity, position, acceleration, these are all vector quantities. And in equations of motion, listen to me, positive negative sign indicate direction of those vectors. So when you find v, you get answer plus minus 10 root 2. Now you will have to take decision which is the correct direction, positive or negative. And how to take this decision? It all depends on the situation involved in the problem. It can be positive answer correct, it can be negative answer correct, or it can be both answers correct. Now in this case, both the answers are correct. How come? I'll explain you little later. Okay. So we have found out v. Just put x is equal to 5, you got velocity. Okay. Now what is next question? Position when velocity is again 0. Position when velocity is again 0. So you want to know x when v is 0. Of course, at origin velocity is 0, it is already given. That is why this word again is used here. That is, once particle starts moving somewhere, its velocity is again 0. What is that position? That is asked in the problem. So simple, put v equal to 0. Put v equal to 0. You want to know x when v is 0. So put v equal to 0 here. So it is cubic equation. Try to understand. That means there are 3 roots, 3 answers for x. Out of these 3 answers which satisfy v equal to 0, velocity equal to 0 condition, there are 3 answers. Out of which one answer we already know, that is when x is equal to 0, v 0. The other 2 answers we want to find out. So if you proceed with the calculations, when you put v equal to 0 here, again you will find that first you get x squared and root of that it should be plus minus 3 root 5. You get answer positive negative because it is root of x squared is the answer. Take a pause, complete the calculations, put v equal to 0, check how you get the answer x. You will get first x squared and then x is equal to plus minus 3 root 5. But here we should discard that negative answer. Here correct answer is only positive. So x is equal to plus 3 root 5, that is the answer. Now, when velocity is maximum, what else is asked in the problem? Maximum velocity. Now, this is very important to understand. Acceleration, velocity, position, these are the variables involved in these three equations. If you want to know velocity or acceleration or position, matlab instantaneous value of any of these three variables you want to know, ask yourself which is that variable whose value at that instant is known. For example, you are asked to find velocity when x is 5 centimeter. So which is to find velocity, what do you know? X as 5 centimeter. So simply put x 5 centimeter, you get velocity. Then position when velocity is again 0. So we are asked to find position when velocity is 0. Okay. So what do you know here to find this position? Velocity is 0. Now you are asked to find maximum velocity. So to find maximum velocity, which other variable whose value is known? Other variables in the sense in this problem, velocity to be found out, maximum velocity to be found out, whether you know acceleration, whether you know position. Okay, acceleration is known. We know that when velocity is maximum, acceleration is 0. So put that acceleration 0 in equations of motion. Now acceleration is involved in equation 1. So put acceleration as 0 in equation 1 and you will get x is equal to, now listen, when you put a equal to 0 and you continue with the calculation, you get value of x squared and then root of x squared, you will get plus minus root 15. But I have chosen positive root here and that is the answer. Now this is very important to understand here, that is for x I am using only positive root because x is position, x is vector quantity, position is vector quantity. So positive negative sign define direction. So when you are asked position or velocity or acceleration, you should write answer in magnitude direction form, otherwise you will lose marks. So x is equal to plus root 15. I have discarded a negative sign. When there are two answers, sometimes both are correct, sometimes larger correct, sometimes smaller correct. It all depends on the situation involved in the problem. So when we get x is equal to plus minus root 15, you will have to decide which is the correct answer. How to decide that? I will tell you later. Okay. Now put x is equal to, otherwise listen, just put a acceleration 0, you get x. Of course, on calculator screen only root 15 will flash. And with that you will proceed with the calculations without having proper concepts. You will able to arrive at the final answer. But remember, by the time you arrive at the final answer, these intermediate marks you have lost. That is, if it is vector quantity, you should write answer in magnitude direction form. If you don't show direction, in this case direction to be indicated with positive negative sign. If you don't show direction, you will lose 50% of the marks. Okay, let's proceed. Put x is equal to root 15 in equation 2 and at this x, remember this is that value of x when acceleration is 0, that means this is the value of x when velocity is maximum. So put x is equal to root 15 in equation 2 and the velocity you get, that is maximum velocity. Now when you put x is equal to root 15, you will get v squared and therefore two values of v plus minus 21.56 meters per second. So here both are correct answers. So this is how we have found out maximum velocity. Maximum velocity is plus minus 21.56. Remember, you are not asked maximum speed. If you are asked maximum speed, then you should write only 21.56. but that is only magnitude you should write. But if you are asked maximum velocity, you should indicate direction also, and here both directions are correct. So we have solved the problem. Now generally how students solve problem, try to understand, and why they lose marks, try to understand. Simple, replace acceleration by v dv by dx, you will get velocity position equation. Put x is equal to 5 in equation 2 and you get v is equal to 10 root 2, because on calculator screen only 10 root 2 flashes and student write 10 root 2 and then they proceed. What next answer? When velocity is again 0, so v equal to 0, put in equation 2 and they complete the calculations. On calculation screen this answer flashes 3 without any positive negative sign, 3 root 5, and they write this as answer. Then when velocity is maximum, put acceleration 0, they get x as root 15. Then they put value of root 15 in equation 2, they get answer 21.56. They don't think at all about these are all vector quantities, directions are associated with these answers. They don't think at all. They just write all these magnitudes in the answers and they think that they have solved the problem. So put and get the answer, put and get the answer without knowing anything what they are doing. Such a person cannot be an engineer. So now listen, these are the correct answers. V plus minus 10 root 2, but x is only positive. X is only positive and v plus minus 21.56 meters per second. Now, how to decide that? So it is very simple actually. Just visualize the motion. When x is equal to 0, what is acceleration? 90. Put x is equal to 0, that is at origin when particle starts. Clearly mentioned here, particle starts with 0 initial velocity from origin. So from origin means x is equal to 0. So when you put x is equal to 0 here, you get v equal to 0. It means when x is 0, v is 0, but is acceleration 0? No. What is acceleration? You will get positive 90. That means particle accelerates in positive direction. So say path is x axis, that is x coordinates are changing, position means a coordinate. So it moves in positive direction, particle moves in positive direction, it starts moving in positive direction. This is how you must be able to visualize the motion. So I am going to help you to visualize the motion. It's very simple of course, but try to understand. Check here, this x axis is path of the particle. Particle starts at origin, that is x is equal to 0, and at origin velocity is 0, but is acceleration 0? Put x is equal to 0 and acceleration is 90 centimeters per second square. What does that mean? Even if velocity is 0, it is on the verge of changing. There is change in velocity because acceleration is there, and this change in velocity is occurring in positive direction. It means particle starts moving in positive direction of x, and this is how particle starts. Its velocity increases, somewhere its velocity becomes maximum and then speed reduces and particle stops somewhere. So during motion, when velocity becomes 0, particle changes its direction of motion and then it returns and again it stops at origin, because at origin velocity is 0. When x is equal to 0, velocity is 0. So when at origin its velocity becomes 0, it changes its direction of motion again, accelerates in rightward direction, somewhere its velocity becomes maximum, then velocity reduces, it stops again at extreme position, velocity is 0, it changes its direction of motion, and this is how particle moves or oscillates between these two extremes. Here velocity is 0 at origin, so here particle, when particle returns here, it changes its direction of motion. That means particle does not move on the left side of origin, and therefore negative x coordinate is impossible. Particle does not crosses origin on the left side. For that purpose, what you should know, when velocity is 0, particle changes its direction of motion. Now try to understand how we answered this question. Particle starts moving in rightward direction because initial acceleration is 90, that is when x is equal to 0, acceleration is 90 positive. So particle starts moving in rightward direction, and what is asked? determine velocity when x is equal to 5 centimeter. So when x is equal to 5 centimeter, x coordinate. So here we found out velocity. X is equal to 5 centimeter. By putting x is equal to 5 centimeter here, we got velocity as a 10 root 2, positive negative sign. And that is what I explained you here. Listen, at x is equal to 5, because it is oscillating particle, it has rightward velocity as well as leftward velocity, and that is why at x is equal to 5, it is plus minus 10 root 2 centimeters per second. B is 10 root 2 centimeters per second. In decimal format, this is the answer. Plus minus. It has positive direction velocity, negative direction velocity. What next? Position when velocity is again 0. So we are asked to find out when velocity is again 0. So here particle changes its direction of motion. So we have just simply substituted v equal to 0 here. So here velocity is 0, say. So we have found out, putting v equal to 0, x. So here we have found out position by putting v equal to 0, 6.708, nothing but 3 root 5. So particle changes its direction of motion. What is acceleration here? Are you curious to know? Put x is equal to 6.708 or x is equal to 3 root 5 here, and you get acceleration as minus 180 centimeters per second square, minus 180 centimeters per second square. So here velocity is 0, but acceleration is not 0. That is why we don't say that particle has stopped here. We say that particle has changed its direction of motion. If velocity and acceleration both are 0, then we should say that particle stops. Particle has stopped here. That is what we can say when velocity and acceleration both 0. But in this case, acceleration is negative. Even if velocity is 0, it is changing because it is accelerated body, and it is this change is in the negative direction. That means it starts moving in leftward direction. And now we are asked to find out maximum velocity. So when velocity is maximum, acceleration is 0. So we have substituted acceleration 0. Calculated value was plus minus root 15. But as I have already explained you that particle negative root 15 impossible. Negative x coordinate is impossible. So we use positive value only. Here particle is moving rightwards, and after some time you will find it's moving leftwards. So both directions for velocity is possible, but both directions for position impossible. Position means a x coordinate and it cannot be negative. Particle never moves on the left side of origin. So visualizing the motion, it's very easy actually. And remember, always you will not have to do this. When you get plus minus sign, or when you solve a quadratic equation and you get two answers, then you will have to stop and think on this, which is the correct answer. Of course, we are going to solve some more problems on overall kinematics, so you will understand that such situations occur in many other topics also. Read this problem. Acceleration of a train is given by a is equal to 8 divided by v squared plus 1 meters per second squared, where v is velocity of the train in meters per second. Determine velocity of the train when its displacement is 20 meters and its displacement when velocity is 64.8 kilometers per hour. You know how to solve the problem. If acceleration is given as function of velocity, then replace acceleration by dv by dt if you want velocity time equation, and replace acceleration by v dv by dx if you want velocity position equation. In this case, check what is asked. Determine velocity of the train when its displacement is 20. So velocity when displacement is 20. So you need relation between velocity displacement, and displacement when velocity is 64.8 kilometers. So you need again displacement velocity equation. Acceleration is 8 divided by v squared plus 1. Replace acceleration by v dv by dx so that you will get vx relation. Separate the variables. Take velocity on the left side, position on the right side, x on the right side. Integrate it and you will get the relation. But constant of integration you will have to evaluate. Integration is simple, x raised to n plus 1 by n plus 1. But to evaluate this constant of integration, what information you have, let's check it. Acceleration of a train is given by a is equal to 8 divided by v squared plus 1 meters per second squared, where v is velocity of the train in meters per second. Determine velocity of the train when its displacement is 20 and its displacement when velocity is 64.8 kilometers per hour squared. So there is no information that appears in the problem. It appears that there is no information in the problem to evaluate this constant. When not given, remember, and this is very important now I am telling you, if not given, assume that motion starts at origin with no initial velocity, means at t equal to 0, v0 and x0. So we are going to use condition here. When x is 0, v is equal to 0. So put in equation 1 and you will get c equal to 0. Put c equal to 0 in equation 1 again and get the relation between v and x. So this is that relation required in this problem to answer the question. Find velocity when displacement is 20 and find displacement when velocity is 64.8 kilometers per hour. Okay. So these are the two necessary equations of motion. Let's proceed. So these are the two equations we are going to use. Put x is equal to 20. Now watch here. Fourth degree equation it is. I have just written this statement in the form of quadratic equation ax squared plus bx plus c. Ax squared plus bx plus c equal to 0. But here x means v squared. So if you consider it as a quadratic equation, you will get two values of x. Those will be two values of v squared and get two values of v squared. So v squared is equal to 24.32 and v squared is equal to minus 26.32. So this is how calculator will give you two answers. V squared is 24.32. Now why we should discard it? Try to understand. V squared is negative, so its root will be imaginary. So of course it's a logical answer. And v squared is equal to 24.32, that means v is a plus minus 4.931. Plus minus. But I have selected positive root. What is the reason behind that? Listen, in the last problem I explained you how that particle was oscillating. Is that train is oscillating particle? Okay, that is okay, it's common sense, but still if you want to check it carefully. Now is negative direction possible? Means whether train changes its direction of motion. Just that is what you will have to check. And how to check whether train changes its direction of motion? Put v equal to 0. If you put v equal to 0, you will get only one answer for x, and that is 0. What does that mean? That at origin, that is when this train starts, only and only at that position its velocity is 0. And once it starts, its velocity never becomes 0. Because velocity 0 is only at x equal to 0. So just put velocity 0, because when particle changes its direction of motion, v becomes 0 momentarily. And that is why putting v equal to 0 in equations of motion, you realize that whether train has changed its direction of motion. So here train doesn't change its direction of motion, so you should use only positive answer. So put. Now second part of the problem, you are asked to find displacement when velocity is 64.8 kilometers per hour. So 64.8 kilometers per hour, that is 18 meters per second. In equation 2, you are going to put 18 meters per second, not 64.8 kilometers per hour. Hours, in seconds it is 3600 seconds, and kilometer, in meters it is 1000 meters. So 1000 by 3600. You must be knowing how to convert v, kilometers per hour, in meters per second. Okay, let's proceed. Just put v is equal to 18, v is equal to 18 here, and you will get x. So this is the answer. Next problem. The acceleration of a train is given by A is equal to 8 divided by V squared plus 1 meters per second squared, where V is velocity of the train in meters per second. Determine time taken by the train to travel 3 kilometers. Determine time taken by the train to travel 3 kilometers. Okay, so here this displacement is involved and also here it is time involved. So we'll have to create necessary equation. Replace acceleration by v dv by dx and also replace acceleration by dv by dt. Displacement is involved. So in this statement we have brought into the picture displacement by replacing acceleration by v dv by dx, and also you should replace acceleration by dv by dt. So replace acceleration by dv by dt for velocity time relation. So separate the variables, integrate properly, simple integration it is, and you will get velocity time relation. But not yet, this constant is to be evaluated, and as I told you, if not given, always assume that motion starts at origin with no initial velocity. So at t equal to 0, v is equal to 0. Put it in equation 2 and you will get c is 0. So finally, the correct equation relation between velocity and time is ready. So these three equations are required to solve the problem. In the last problem, it was the same train, but this relation was not required. We could answer the last problem with velocity position equation. That is how that question was. But here time is also involved, and that is why we got this third equation. So now we'll answer the question. Where v is velocity of the train, determine time taken by the train to travel 3 kilometers. You want to find a time, okay, we'll find. But what is given? Displacement. How much is that? 3 kilometers or 3000 meter. So put in second equation x is equal to 3000 meters. So this is how you will get the second equation. Write it in quadratic equation form. You will get two values of v squared. Square root of negative value is illogical answer. You will get two values of v, but of course negative v is impossible here. Its train, once it starts from origin, it never changes its direction of motion. How will you come to know? Put v equal to 0 and you will get only one value of x, and that is 0. That means only at origin particle's velocity is 0, and once it leaves the origin, nowhere x is 0, means nowhere velocity is 0. So this is the velocity. But that is not asked in the problem. You are asked time taken by the train to travel 3 kilometers. You want to know t. So which is that velocity time relation? Equation 3. So put v is equal to 17.57 meters per second in equation 3 and you will get t. So this is the time. But we'll keep it in seconds only. Actually, there is a key on calculator that gives you directly answer in degrees, minutes and second. That degrees means hours. Degrees, minutes and second. Check all the keys and on which key degrees, that is 0, minutes, that is 1 comma, and seconds, that is 2 commas. Use that key and you will get this answer. 3 minutes and 48 seconds. This is better way to give the answer. Thank you.